Hello. In the series of probability distribution functions, today I will be discussing about the student's t distribution. The t distribution, it is also known as the student's t distribution, is a type of probability distribution that is similar to the normal distribution with its bell shape but has heavier tails. The tails are heavier. It is the crucial point here. Okay. In the normal distribution, the tails are not heavier. Here in the student's t distribution, the tails are heavier, and it is because of the degrees of freedom. If the degrees of freedom are large, then it would be the student's t distribution would be the standard normal distribution with zero mean and one standard deviation. If degrees of freedom is suppose 20, as you can see in our figure, the blue solid line represents the student's t distribution. As the degrees of freedom is 20, as the degrees of freedom is 20, so there is a heavier tail. There is heavier tail. You can find the heavier tail. When the degrees of freedom is 10, the t distribution would like a black solid line. You can see the black solid line, and the tails are much more heavier, with smaller values giving heavier tails, with higher values of degrees of freedom, making the t distribution resemble a standard normal distribution with zero mean and standard deviation of 1. Okay, now now look at this. The interval estimate of a population mean small sample case. Here one thing should be mentioned, that the number of observation should be less than 30. In case of normal distribution, it is here n greater than 30. Number of observations greater than 30. This is the interval estimate of the population mean small sample. Okay, x bar. X bar is the population, is the sample mean. It is the sample mean. It is the it is the t it is the t. It is the value of t with alpha by 2, with t alpha by 2 with suffix is the t value, providing an area of alpha by 2 in the upper tail of a t distribution with n minus 1 degrees of freedom. Okay, t alpha by 2 is the t value, providing an area of alpha by 2 in the upper tail of a t distribution with n minus 1 degrees of freedom, and s is the here s is the sample standard deviation, and it is the sample standard deviation, and it is the observations. N is the observation. So by using this formula, the interval estimate of population mean for small sample you can find. For now look at an example. I can mention here one example. Suppose you can collect a sample of 29 statewide life insurance policy holders. Okay, and the age of the 29 statewide life insurance policy holders, and the mean, and you find the mean of that sample, and you get that is the 39.5. This is the point estimate. This is the point estimate. But you do not know the population mean, that is mu. You do not know the mu. So here an error will lie. That is mu minus sample mean. Population mean minus sample mean is the sampling error. Is the sampling error, and in this way you can find the error part. In this way you can find the error bar. Sampling distribution shows how the sample mean values are distributed around population mean. So sampling distribution shows how the sample mean values are distributed around mean, population mean. Sampling distribution actually is providing us with information about the possible differences between the sample mean and the population mean. That is the sampling error. Possible sampling error. If you see this curve in my previous slide, you can find suppose this black solid line is the t distribution curve. Okay, so this curve, suppose suppose this portion covered by these two lines, this whole portion shows the 95%, suppose the 95% cases where the sample mean where the sample mean differ from the population mean by by 2.73. Suppose look at this, look at this 2.35. The error is 2.35. Okay, with this error, for example, I have said that the mean is 39.5 and standard deviation is 1.2. Standard deviation is 1.2. Okay, so in here this 2.35, the 95% of all sample mean values are within the plus minus 1.96 multiplied with 1.2 of the mean. So this is the error. This is the sampling error. With this sampling error, the 95% sampling mean with 2.35 years, the sampling mean differ from population mean. Now here you can see the alpha, the term alpha. Okay, what is the alpha? The Greek letter alpha to indicate the probability that a sampling error is larger than the sampling error in the statement. Larger than the sampling error in the statement. It means that sampling error in the statement is 2.35. It is larger than the sampling error. It means this probability, this area is represented by the alpha. Okay, this area, and this area is represented by the alpha. So this portion is nothing but the 1 minus alpha. So this portion is nothing but the 1 minus alpha. Okay. Now, so 1 minus alpha will be the area probability that a sample mean will provide a sampling error less than or equal to the sampling error in the statement. That is 2.34. less than or equal to 2.34. Sampling mean differ from the population mean with an error 2.34, equal to 2.34 years or less than 2.34 years. This area represents this. Okay. Now alpha by 2 means the area or probability in each tail of the distribution. Okay, alpha by 2, because it is alpha, this plus this is alpha. Alpha by 2 means this portion only. Alpha by 2 means this portion only. Okay, so hope you have got the point of what is the 1 minus alpha. The 1 minus alpha is the probability or the area, or it is also called the confidence coefficient. It's also called the confidence coefficient. In our picture, you can say this portion is called, if I draw a line, from here, straight line, this is straight line, this portion covered by these two lines is 1 minus alpha, and this portion is alpha by 2. This portion is alpha by 2. Okay, so this portion represents the area. I have mentioned that the area, the sample mean and the values of sample mean differ from the population mean by 2.34 or less, and this portion represents the sample mean, and the difference between the sample mean and population mean is more than 2.34. It's more than 2.34. Okay, so now so so this is the confidence, this is the confidence interval. 39.5 plus minus 2.35 is the confidence interval. A 95% confidence interval estimate of the mean age of the population of a statewide life insurance policyholder. This is the result. This result shows this. Okay. As an example here, we find that 95% of the value of a normally distributed random variable lie within plus minus 1.96, plus minus 1.96 multiplied with 1.2. That is the standard deviation. That is the standard deviation. Okay, so this is the t distribution. So in this lecture I try to cover the what is the students t distribution, and where the difference exists in between the normal distribution and the students t distribution, and when the students t distribution becomes the normal standard distribution, and what is the role of degrees of freedom I have mentioned, and what is the alpha, and what is the sampling error, with an example of statewide life insurance policy holder. I have tried to clarify this the students t distribution, and I hope you have enriched your knowledge by this lecture, and thank you for enjoying this lecture.